scientists have discovered a startling possibility. After expanding, the universe may one day begin to contract. The Big Bang may not have been the beginning, but a cosmic rebound. From childhood, we're taught a clear story of the universe's origin. 13.8 billion years ago, an infinitely hot, infinitely small point exploded. Matter expanded and cooled, forming galaxies, stars, and the Earth beneath our feet. This is the official model of modern astrophysics, supported by two key discoveries. In the 1920s, Edwin Hubble found that galaxies are moving apart. And in 1965, scientists detected the cosmic microwave background, the afterglow of the early universe. So the Big Bang entered textbooks as fact. Yet one crucial question was avoided. What came before the beginning? We can prove the universe is expanding, but not that it must have started from an infinite point. Behind this elegant model lies a deep flaw. What existed before the Big Bang? Physics is built on cause and effect. Apples fall because of gravity. Planets orbit because mass bends spacetime. But the Big Bang, the first event, has no known cause. It appears like a miracle from nothing, breaking our most basic logic. According to general relativity, the universe expands. Reverse time, and all matter collapses toward a single point. But this point isn't physical. It marks where our theories fail. Relativity explains galaxies and black holes. Quantum mechanics rules the microscopic world, where particles exist in multiple states. Empty space teems with energy, and electrons jump without passing in between. These two theories cannot be unified. Forcing them together at the universe's origin causes mathematics to break down. For decades, we avoided this problem by saying time began with the Big Bang. Stephen Hawking compared it to asking, what lies north of the North Pole? But that is an evasion, not an answer. So physicists asked a deeper question. What if the beginning wasn't a beginning, but a turning point? This idea is called the Big Bounce. In this theory, the Big Bang was not creation, but the rebound of a previous universe that collapsed to its extreme limit. Imagine a basketball hitting the ground. It compresses, stores energy, then rebounds upward. The universe may behave the same way. A previous universe contracted under gravity. At maximum density, quantum effects caused spacetime itself to bounce, turning contraction into expansion. That rebound is what we call the Big Bang. In this model, the universe has no beginning, only endless cycles. Contraction, bounce, expansion, then contraction again. 13.8 billion years ago was not the birth of everything, only the start of our current expansion phase. Before us, there may have been countless universes, some similar, others with different physical laws, different galaxies, perhaps even different life. In the distant future, expansion may slow, reverse into contraction, and prepare for another bounce. This idea rewrites the age of the universe. It is not finite. It is eternal. Time has no beginning or end. The universe endlessly renews itself. But if a big bounce occurred, can we detect traces of a previous universe? This is one of modern cosmology's greatest questions, a form of cosmic archaeology. The best clues lie in the cosmic microwave background. It is not perfectly uniform, but filled with tiny temperature fluctuations, the seeds of future galaxies. Some physicists predict a big bounce could leave subtle patterns there. So far, our instruments aren't sensitive enough. From 2009 to 2013, the Planck satellite mapped this radiation precisely, but couldn't separate signal from noise. In the 2030s, the LISA Space Observatory may finally reveal the truth. If the Big Bounce is confirmed, we face a radical reality. The universe is eternal. Time has no origin. Space has no boundary. Expansion and contraction repeat forever. This doesn't just change our view of the universe. It changes our view of existence. We are not living at the beginning of everything, but within one phase of an endless cycle, inheriting matter from a previous universe, guided by timeless physical laws, perhaps carrying faint traces of a cosmic past. The Big Bounce remains a hypothesis. It solves the problem of a beginning, but lacks definitive proof. Yet its value is clear. Science is not about fixed answers, but about questioning what seems certain. From geocentrism to heliocentrism, from Newton to Einstein, knowledge advances by breaking assumptions. The question is no longer how the Big Bang happened, but whether it was truly the beginning at all. That single question opens a new horizon. The universe may be far older than we imagine, having already lived through countless cycles, long before we ever looked up at the stars.